Alright, hello again. Here is for Chapter 6.2, Chapter 6, Section 2. How a router routes. Okay, that makes sense. So, there's three options. Router to itself, which is 172.0.0.1, which is basically just to make sure that the protocols for that router is working, for that NIC is working. And it has localhost, which is things that are directly connected or very shortly connected within its network. The remote, that's outside its network, or past its network, past what their the local area. And we'll explain that in a little more detail in a little second here. Now the key thing is, the difference between localhost and remote host is this default gateway. The default gateway is the router that ends that network. It's basically the door out. So it's basically if you have a building, an apartment building, all the apartments are within your network, within the building. The default gateway is that door out of the apartment building. So, the default gateway routes it to other networks. That's what things go in and out. Again, it's the gateway to your network. So the IP address of that gateway is the IP address of your NIC of your router that's facing you. So on a router, every NIC has, every port, every interface has its own IP address. Unlike a switch, where the switch has its own IP address for the whole thing, each port on a router has an IP address. And that's important. So everything within there is a local network. Everything out there is a remote network. How do you do this? Well, if you go to your PC at home, this is your PC, not a switch, not a router, your PC yourself, type this in, it'll tell you destination, network or addresses, the send the mask for it, and how to get there. The interface to go through right here. It'll tell you, and I'll give you this priority level. You have quite useful. So, now how does this apply to your router? Because we're talking about routers now, remember? Well, your router is right here. Whatever's connected to that router is part of the directly connected networks. So as we said, each port has an IP address. Each port has its own network, typically. So in this case, R1 there, here, R1, has 3 directly connected networks. Now past that, to R2, past this directly connected network, we have 2 remote networks, right here and right here. We also talked about a default route. Default route is a last resort. Basically outside, out into the internet. Basically, if it doesn't know what to do with it, just shove it out the door. Basically, a mailman comes in, says, hey, I have this mail for this person, and somebody there says, no, nobody lives in this apartment. Go outside, it's somewhere out in the rest of the world. Maybe he'll find it, maybe he won't, but he knows it's not that network. So how do you do it on a router? How do you find these routes? Right here, show IP route. And then it gives you a big giant list. The more routes you have, the bigger it is. See, look at that. These 3 here are the directly connected 3, and these 2 here are the remotely connected ones. These are remotely, well, it tells you the type of protocol that found it. C's and L's are for remote or local connected, or directly remote or local connected. Give this video a watch. I'm not going to make you watch on a video, so that's kind of weird. You can do it yourself. So, that list that you saw there, that first column right here, the C and L tells you how the network is learned. Well, C and L means it's directly connected. The C is the network address. The L is the port address. So it tells you the port the port that goes out to this network. It's directly connected and tells you what interface it's connected on. It tells you, this middle part here tells you what network it is, how it was learned, and this tells you what interface it's on. So 0 right here. 0, 0 tells you this is the network and this is the port. The .1 right here is the port identifier. Remote. Well, it's a lot more for remote. This tells you how they found it, because you see there's multiple ways to find it. You can put it in yourself. eGrip, OSPF, these are probably going to be 2 most common ones. This is the network you're talking about. This is the trustworthiness or administrative distance. This is how good of a connection is. Lower number is better. Again, this one, lower number is better. This is IP address it goes to. So in order to get to this network right here, it knows it needs to go through this network, through the port, not that it is on its machine, but the port that it talks to on the other end. Identifies a latency, or sorry, identifies the last time it was checked, which is 5 seconds ago. And what connection? The serial connection. Next hop. Oof. A little confusing, but it's nice. Via. See right here? Just wanting to get to this network. Yeah. Wanting to get in this one and this one. And it goes via this connection. Tells you the next hop. This is the next spot. And this says right here, this guy should know how to get to here into here. That's what it is. That's what next hop is. It tells you the next spot to go. So if you're driving down to St. Louis, it tells you your next stop is the intersection in town. And that guy will tell you his stop is, or this your next hop is, the intersection at Fargo, or in relation to wherever you are. Again, a nice little video. I'll give you a little different perspective than mine. Should be nice. Go through this, see if you remember which one these are. That's my guesses. And there you go. That's it. A short little one. I will do 3 again with the next video.